x, the points across the x-axis will be 2 and 1 and minus 1.
Yeah, 2, 1, minus 1. What about y-axis?
-2.
Yep. -2. And then you would just join those up. Hold on. It goes the other way. This will make a negative quadratic. The only way I can do it without creating another root would be like that. Okay, I think you're good for that. Fine. How does the first one? How do you do this first one?
So it crosses the x-axis as -1 and it touches it at 1, I think.
Yes. 1, -1. Y-intercept?
1.
Yep. 1, and like you said, it touches it at -1. It goes there. It's going to be something like that. How do you do B?
So you have to expand, factorize it.
Sure you do. Calculator?
Okay. So x equals, so x, it crosses at 3, -1 and 0.
0. Y-intercept?
0.
Yep. And so that's going to look like that. And then this last one, that is C. Just write the brackets out 3 times. X -2, X -2, X -2, and then just do it the same as the others.
Okay.
You'll be fine, you'll be fine. Cubic graphs. Let's just see. Yeah, fine. 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 So how would you do this one?
I think you need to factorize the second part. So kind of confused.
What were the solutions for the second part?
Stuff with imaginary numbers.
Press equals again. What's the minimum?
-1/2.
And what about the y part for the minimum?
1.75.
1.75. So in that case, where do we know it crosses the x-axis?
-0.5.
Nope. Based on brackets.
Oh, 1.
So 1, and there's no. It doesn't cross at any other point. That's what, because they're imaginary numbers. Y-intercept?
0.75.
No.
Why? Oh, -2.
Yeah, -2. And so this is going to make a cubic that looks something like that. That's it. There you go.
Okay.
So let us try. Let me think about this. Yeah, what is. How do you do 3a?
So it crosses the x-axis at 2,
Mm-hmm.
and then crosses the y-intercept is -6,
Mm-hmm.
and the solutions of the second one were like imaginary numbers.
Mm-hmm.
So what do we do with them?
You would just draw it. So if they're just imaginary numbers, then there are no other roots. Doesn't cross the x-axis at any other
Oh,
points.
right.
Yeah.
Okay.
Okay. Yes. This is exam question. Okay, what is part A?
How many marks is it?
2.
So can you just use your calculator or?
Always, unless it says using an algebraic method.
So x plus 4 and x minus 1, and then just x by itself.
So x by itself. So that would give you x. That's x squared plus 8x plus 16. How did you get x plus 1 or something?
Yeah.
How did you get that?
Or x minus 1. I don't know. The calculator just told me that.
For the cubic?
Yeah.
Did you put it in right? 1, 8, 16, and 0?
Yeah. So it'd be x minus 1 because x equals 1. So,
Hang on. So, I'll change that to cubic. 1, 8, 16, 0. So that's x plus 4. That's it. So there's no x plus 1. Where are you getting that from? 1, 8, 16, 0. Are you putting in a quadratic or something?
no.
Is your calculator same as mine?
Maybe. Oh, it's just, yeah. You know now how it goes back to the one? I just thought that was one of the answers.
Ah, okay. Okay, so what's this about? It only gave us 2 answers. Minus
Yeah.
4 and 0. So you correctly said x and x minus 4.
Yeah. So how do you get the cube?
Well, if you were to do this GCSE style, x squared plus 8x plus 16.
X plus 4 is like twice. X
Yes.
squared.
And so, yeah, the calculator just didn't show the same answer twice.
Yeah, okay.
And so it's that squared. And so just watch out for that. Okay, how about this one? A.
got mm, says x equals 2.5 and x equals minus 2.5.
So x equals, I'll write it as 5 over 2.
Yeah.
Make that equal to 0. How would you rearrange that to make it equal to 0?
I'm not sure.
Times both sides by 2.
2x equals 5.
And then what is that if it was equal to 0?
2x minus 10 is equal to 0.
2x minus 5.
Yeah.
And so what's one of the brackets?
5 over 2.
2x minus 5. So, in GCSE, it's like,
So yeah.
Either the first bracket is 0 or the second bracket is 0. So same thing, x equals minus 5 over 2.
So 2x equals minus 5.
Mm-hmm.
And then 2x plus 5 is equal to 0.
Mm-hmm.
So that's the other bracket.
What's the other bracket?
2x plus 5.
And was that everything? What was the other solution? What does that tell you?
Just x.
Yep. That's it. Well done. Any questions there?
No.
So we're like solving these in reverse. You can always do them GCSE style, non-calculator style. So 25 minus 4x squared. And that would be difference of two squares and all that.
Yeah.
Let's see. Is this worth it? I just want to see. We could. Hey, where do you go? Yes. Okay, how about this one?
Please, can you move it down a little bit?
Yeah, chicken does, man. I just move it. Hold on. Before we jump into this one. What is this?
So x minus x plus 1. And x minus 2, x minus 3. And then we expand to get x squared plus.
Oh yeah. Hold on. What y-intercept would these give?
6.
So this is 2, and so what's going on there?
Don't know.
We would have to. So let's say, the way x equals. Let's say x equals 3. Is there that could be the same? Like x equals 3. That could have originally been something like 2x equals 6. That type of thing.
Oh, right.
Or something like that. And so is there any of these brackets we can change so that we end up with a 2 there? Or what would we have to end up with a +2?
2 negatives and a positive.
Yeah. And so what times what will give us 2?
1 times 2 times 1.
So let's say she said 2 negatives. So I'll do -2 and -1.
Yeah.
And so which one got changed?
And the -1.
Yeah. And so what must that bracket be so that you get an answer of x equals 3?
I'm not sure.
I'm not sure either. Let me go back a second. This one. What would this one be?
X plus 3, x plus 2, x minus 1.
2, x minus 1. And that gives us a y-intercept of -6, and then you just expand it. Let me just see. Yeah. That's. So how are we supposed to know this one? Let's see. So it would be 1 -2 -3. They make +6. So we have to times by a third. I think it would just be like a third on the outside or something. Is A just a third? And is that way you do it? So I think it would be 1/3 on the outside. Yeah. Do I have the answer? Oh, I do. Yes, it's just a third. That's cheating. Okay. And then we could use that for this one.
The graph.
So we could try getting the. If you're not sure where they went wrong, just try it yourself.
X minus 6, x plus 6. Is it that the x plus 6 is the one that's meant to be squared?
Yep. And is that correct? If we put in -2, do we get 32?
What do you mean put in -2?
When x is -2.
Oh, you get -128.
28. We were supposed to get 32.
Yeah.
So what do you do there?
So we need to like change one of the brackets.
Sure. Minus 128 over A gives you 32. What is... Or I suppose I should just say times A. What is A?
$32 divided by minus 128 gives you minus a quarter.
So, what is the equation of... what do we do with that minus quarter?
You put a quarter in front of x minus 6 and that.
Yes, minus a quarter.
Oh.
X minus 6, x plus 6 squared. There we go. So strange, I never would have thought of that, but that's what it's saying in the exam questions will take the shape of. And so, explain the student's mistake.
Well, they put the x minus 6 as a squared, but it should have been x plus 6 squared.
Yeah, that's true. So they made two mistakes. That's a good one to pick. Yeah, I like that one. Okay, and then they expanded out. Okay. Let's see this one. Coming in this form, A, B, and C. I think that one's alright. Similar. Oh, they're very similar. Okay, let's try this one.
So x plus 1, and then x minus 2, x minus 5.
And is that correct?
No.
Why not?
That times to 10.
Right. So what do we have to do?
Change the bracket.
What would you have to change it to? So you would end up with 30.
Three x minus 15.
Yeah. So any of them times by 3, and I could just put the 3 on the outside.
Oh.
Yeah. And you could, yeah, so A is 3, and then the rest of them you would just fully expand.
Okay.
Let's see. Let's factorize completely. How would we do question A?
Is it like a function?
No. That'd be the same as if it was like y equals or something.
So you have to like expand it out.
And after you fully expand it?
What do you mean?
Yeah, you're right. Fully expand, fully simplify. I think you'd be okay for that one. Cubic graphs.
Half.
Right, quartic graphs, quarter, power of 4. This is what they look like. So this one looks a lot like x squared, but it's x to the 4. This one has 1, 2, 3, 4 roots. And then this one has 3 roots because it has one repeated root where it touches in the middle. Sketch the first one. Nah. Sketch the last one.
So draw X touches 1 and X touches 3.
Okay.
So is it like kind of like a W?
Yeah. So it's like that.
Yeah.
Y-intercept.
Three. No. 9.
Great. And there it is.
Okay.
Just looking for, okay. Yeah. Too easy. Hang on. Sketch this graph. How would you do this?
So type in on our calculator. Okay, so X crosses -5 and +4.
Mm-hmm.
And then the other, if you type the other one in the calculator, it gives you imaginary numbers, so it doesn't cross.
Okay, so it doesn't cross any other one. So this is a quartic. So maybe it's kind of like that a bit or something. Y-intercept.
Is it -20?
Be -20 times 14.
Oh. -280.
Yes. And so, yeah, if you're ever not sure, just get the y-intercept as well, and that will tell you where it'll cross, like what quadrant, what half of the y-intercept it'll cross on. And that'll help to do the sketch. Okay. How about question 5? No. Hold on. Too easy. Too easy. All right. Quartic graphs. I'm putting you down for good. They're very, very similar to the one that came before.
Okay.
Reciprocal graphs. So 1 over x, y equals 1 over x. It's in the first and third quadrants. Y equals minus a over x will be second and fourth quadrants. So they'll swap because it's a reflection. This one here, y equals a over x squared. So top quadrants, and then minus a over x squared, bottom quadrants. And I'm saying a because it won't matter what number is on the top. 1, 2, 3. If it's positive, it'll look roughly like that. So what will a look like?
So is it in the first and third?
Yep.
So you draw one line close to the thing, and then another one like a bit out from it.
Yeah. Okay. And if they go for long enough, they'll both eventually be, touching each other. Sorry, and this side as well. How about B?
Will it be in the second and fourth, but the same kind of thing?
Yeah. How about C?
The top two.
Yes. Top two, same kind of thing. And they are asymptotes, so eventually they will touch. It's just that the middle bit gets spread out a bit. They drew them parallel as well. Yeah, I'm happy. Fine. Yeah, you murdered those questions. We're not doing any of those. Exam questions. No. Yeah, sorry. 5. Let's do 5. And the important bit is question B. In fact, I'm done A. So that's that. Whoops. That's that. Okay. Equation of the asymptotes.
What does that mean?
The line that they get close to but never touch.
Quite confused.
The line that they get close to but never touch is the x-axis. So that's that there. And also the y-axis. And so what is the equation of each of those lines?
Each of the x-axis and the y-axis.
Yep. So let's say, what's the equation of the y-axis?
Y? I don't know.
X equals 0.
Oh.
0, 1, 0, 2, 0, 3. And for the x-axis?
Y equals 0.
Yes. That one, next one's very similar. So x equals 0, y equals 0. That's reciprocal graphs. Okay. 6. Let's do the question 6.
So on the second and fourth is the minus 3 of x. And then the other one is on the bottom 2.
Okay.
Yeah.
And B?
Is it the same again?
It is. And it won't always be. Like transformations, they might move it up by 3 or left by 5. And that would change things a little bit. I just want to see something here. Red is the minus 3x. Yeah, that's fine. Reciprocal graphs.
2.
Points of intersection. Skip A. How would you do B? If you drew both of these graphs, how do you find out the points of intersection?
You don't use simultaneous equations.
You do use simultaneous equations.
So do you have to draw the graph out?
Just imagine I drew the graph.
Okay.
How would you then go about it?
Where they cross the roots.
Where do the lines cross each other?
The point of intersection.
Yes, Keelan, but how do you find its coordinates?
Doing simultaneous equations.
Do it. How do you go about that one?
So for the first one, the y equals x bracket x minus 3. would you like rearrange it and stuff?
To be what?
Y equals x squared minus 3x.
Okay.
And the other one, y equals x squared minus x cubed. And then set them, they're equal to each other.
Yes, that's the important bit. So simultaneous equations is when the two equations are equal to each other. And then you would solve that. Okay, go for it.
So the x squareds cancel out.
Mm-hmm.
And then you get x cubed minus 3x.
Mm-hmm.
And then what?
What is that equal to?
I'm not sure.
0. You brought the
Why?
minus. You brought this over, didn't you?
Yeah, okay, yeah.
Caoilfhinn. Calculator. X cubed is 1. A is 1. That one's 0. That one's minus 3. That one's 0. Root 3. Oh, there you go. Minus root 3 or x equals 0. We want the coordinates. How do we get the y coordinates?
Sub it back into.
Yeah. And so when you sub in x is 0, what do you get?
0.
Yep. And that's that one there. 0, 0. And then you would do, all right, try subbing in root 3. What do you get?
For x.
Yeah.
Got 3 minus 3 root 3.
Yeah. 3 minus 3 root 3. And I believe the other one, why did I put there? I believe the other one would be 3 plus root. No. That would be root 3 minus 3 root 3 minus 3. I assume. So, yes, 3 plus 3 root 3 and then 3 minus 3 root 3. Yeah, okay, grand. So, important bit is at the points of intersection, they are equal to each other. So,
Yeah.
equate them and solve. Just want to see exam questions. Okay, how about this one?
Can you move it down, please, a little bit? Thank you. You see that symbol thing, the by x and 0. What does that mean?
You can largely ignore those. It means x is not equal to 0. And that just goes without saying. You can't divide by 0.
Oh, right. So 2 2 over x minus 5 is equal to 2x minus 5.
Yep.
So then would you times everything by x?
Sure.
So you get 2x squared minus 5x on the other side. And then
no. Oh, sorry, on that side. Yeah. 2x
yeah, and
squared.
then on this side do we get 2 minus 5x?
Yeah.
So 2x squared minus 2 is equal to 0.
Mm-hmm.
X plus 1 and x minus 1.
So x equals 1 or x equals minus 1. Have we gotten 5 marks?
Need to substitute that back in.
Mm-hmm.
So minus 3 or minus 7.
They asked for coordinates. Let's give them the coordinates.
1 minus 3 and then minus 1 minus 7.
Great. Any questions there?
No.
Beauty. Oh, hang on, sorry. Okay, how do we do this weird one?
Y equals b over x. Is that in the second and the fourth? No. First and third.
Yeah.
I'm not sure about the other one.
Just sub any number in for A.
So like x squared, 3x minus 5.
Yeah, so if A was a 5.
So then it would be, I'm not sure.
You're very sure. X squared, 3x minus 5. Find the points, the roots and stuff.
Expand out.
Okay.
So you're going to get 3x cubed minus 5x squared. So I got x equals 5 over 3 and x equals 0.
0. So did we get the same thing twice, was it?
What? It didn't say that.
This is cubic. So, okay, so how would we now sketch it? So x is 0, x is... So this 5 over 3,
Yeah.
we just let A be equal to 5. And so what would we do now? We would just reverse it.
What do you mean?
So we initially let A be equal to 5.
Yeah.
And so now we would let 5 be equal to A and swap it back.
So now we just sub in a again. Let's go back to the original one.
Into our answer.
So 3x.
Nope.
Yeah.
After that.
A over 3.
Yeah, basically there was no 5. We just did that. So 5 over 3 will
Yeah.
be on the right side of the x-axis, and so this will also be on the right side because it's a positive number. It's just kind of to help us to do that. Okay, sketch the graph. Cubic, what's it going to look like? And you can use 5 if that helps.
So if it was 5, it would cross a 5 third and 0. And does it touch one of those?
Which
Because
one?
there's only 2. How do you know?
It's always a squared one.
5 over 3.
Read the question.
The 0.
X squared gave you, so this one is a linear that gives you one solution, a over 3. This is the squared one, and that's the one that's giving you the 0.
So it touches 0.
Yeah, so that's when it touches. So that goes like that, that, that. And part B?
Uh, 2.
Yep. Why is that?
Because they cross at 2 points.
Yeah. 2 solutions, 2 points of intersection. 2 real solutions. Yeah, great. Wait a second. That is. It was positive cubic. Sorry, I did a negative cubic. It was plus x squared, not minus. I'm a silly Billy. I blame you. There we go. 2 section, therefore 2 real solutions. Okay. Almost identical. Looks good to me. How do we do this one?
So.
One second. Oops, I'm going backwards. This is the very last one. It's not quite it though. Okay, how about this one?
So the y equals b over x is going to be in the first and third.
Mm-hmm.
And then the other one is a cubic again.
Mm-hmm.
So should we just sub in the a again?
Okay.
Or do we?
That was just to help us. You can do that if you need to. You don't have to if you don't want it.
Yeah, I'll do it. So it'll become x cubed, say, minus 3 x squared, so x minus 3 and x plus x is 0. So it's going to touch 0.
Right.
And go through 3.
Okay. And where will the cubic start from on the left side?
The top.
Positive or negative cubic?
Positive.
Therefore?
the bottom.
Yes. So that will touch there, go through there. And number of solutions?
2.
Yes. 2 real solutions. The only one that looked like anything was the very hardest one. No, the very last one. So just A instead of a number. So it's very similar to that one that we just did. So what could A be? Yes. Range of values, you would do b squared minus 4ac to get 2 distinct points. If you get 2 real roots, what is b squared minus 4ac?
Equal to 0.
That's one repeated root.
Bigger than 0.
Yes. Points of intersection. What do you give yourself?
I'm sorry. Tick.
A beauty. Let's go back. So we got 4. What was after that? I suppose I could just use my thing. That was points of intersection. Transformations. Okay, so it's good. So we did all of sketching. Okay, let's take a look. Cubic graphs. You're good there. This one, yes, touching is when it is the squared one. Yeah, you know how to use your calculator to get the roots, also known as solutions. This one, why did we only get one solution for this one?
Because the other were imaginary.
Yes, so that one had no real roots, so there was just one. And don't forget to get the y-intercept as well. So x-intercepts and y-intercept. Why did the calculator for this one say x equals 0 and x equals minus 4 when it's cubic?
Because the x minus 4 is repeated, but it didn't say that.
Yes, so it won't say that, so you'll just have to look at it yourself. How did we get the 2x minus 5 for this one?
Rearrange.
Yes, so GCSE and I suppose lots of A level, it's equal to 0 and you have to solve for x. Here we're like unsolving for x, we're making it back into equal to 0 again. If you don't like that, you can always do it the way you're supposed to, which is factorizing and then difference of 2 squares or whatever. Using calculators, by far the easiest, and in fact people are starting to recommend using it that way because I'm ahead of my time. This stuff, yeah, so the 3 brackets, you just figure that out. Then you just check what the y-intercept is. Our y-intercept was 6. It was supposed to be 2, and so it just have to be times a third.
Okay, yeah.
This one was very similar. It would have to be times minus a quarter. And this one was very similar. We got 10. It was supposed to be 30, so it'd have to be times 3. And you don't have to actually, like, 3 times any of those brackets will work. So 3x plus 3, or 3x minus 6, or 3x minus 15. But, you know, just put the 3 on the outside.
Yeah.
Quartic graph. Yeah, so it had 2 bits that it was touching. That's alright. Don't forget the y-intercept. Quartic graph has that W or M shape. That was okay, I believe. Yes, this one had no real roots for the second part as well, and so that's why it only had 2 points of intersection, only 2 roots. Those are fine. Reciprocal graphs. I think you're good for those, what quadrants they're in. How do you know how many solutions you'll get if you have to find between 2 graphs?
How many points of intersection?
Yes. Asymptote means the line it gets close to but never touches, and so that will come up again when you're doing transformations of graphs. Like if it goes up by 3, then the y will be equal to 3, but the x will still be 0 because it affects the y but not the x, that type of stuff. Asymptote, that weird word. This stuff. How do you find the points of intersection between two graphs?
Simultaneous equations.
Yes. And how do you go about those simultaneous equations?
You set them equal to each other and rearrange.
Yes. And don't forget to sub it in to get the y coordinate. They ask for a coordinate. Give them a coordinate. How do we do this one where they just have a and b instead of numbers?
Just substitute in whatever number.
And then?
Use that.
Don't forget to unsubstitute it at the end.
Okay, yeah.
So instead of 5 over 3, it would be a over 3. This one, instead of 3, it would be a, and so on.
Yeah.
Yeah, how was that for you, Keelan?
Good, thank you.
What are we doing next time? Do you know, or?
I can let you know.
Okay. Any questions for me in general?
No.
Oh, well done. You did great. I look forward to chatting again next week.
Thank you. Have a nice week.
You too. Goodbye.
Bye.